Hey, welcome back. Let's talk about data structures today. What's that to mean? Well, in any computer program, we are concerned with managing data, all kinds of data, and we need some structure, some way to store these pieces of data. And when they're independent pieces of data, like your name or your age, or I don't know, a quantity in your shopping cart of your e-commerce store of your favorite one, then these are independent pieces of data. But sometimes, and quite often, actually, we have to deal with pieces of data that are somehow connected to each other, that relate to each other. And I want to talk about that today. So the first data structure that we're going to talk about is an array. An array is really a collection of elements of the same data type. If you recall, and if you've been listening to my podcast, I talked about data types before. We have alphanumerical data types where we can store all kinds of texts. We have numerical data types where we just store pieces of numbers, basically. And an array is a collection of, for example, either a text type or a numerical type, but multiple items of the same type. So multiple numbers, like the collection, the lottery numbers that are being determined every week. This is an example of an array of numbers. It has a fixed size, a fixed number of elements. I don't know how your lottery works, but here it's 6 numbers and you can store them in a number array. Other examples would be a shopping list. A shopping list could be represented as an array of text items. And you can access these items in the array usually by an index, meaning give me the first element, or give me the 10th element, or give me the 5th element. Okay, so you've got a numerical index, we've got an order there in the array. So one element is always the first element, then there's the second element, etc. And one of the interesting things that some tend to make in software industry in general, well, not as we normal people might expect, is that we begin counting with the number 0 for the index. So actually give me index number 0, the element at the 0th index is actually giving you the first one on the top of the array, so to say. So that's an array. Another type of data structure is a list. A list is quite similar to an array, but it can hold elements of different types. So an array, always the same type. So like the lottery numbers, you cannot store your to-do item there in between the lottery numbers because it's a number array. With a list, that's possible. So lists can store different types of data, but they are still ordered. One element in the list is always the first one, then the second one, and the third one. So that's an order. We can change the order. We can tell the list to order itself alphabetically from A to C or from C to A or numerically for some criteria. And of course, if you store different elements of different types in the list, then the question is, well, how do I order? What's the logical order of these elements? But that's a topic for another discussion. But the important thing to remember is lists can store elements, data types, different data types, and they have an order there. The third data structure that I want to talk about is a set. A set is a collection of unique elements. So with the array and with the list, you could theoretically or even practically store the same number or the same to-do item multiple times, if that makes sense in your context. With a set, that's not possible. A set is a collection of unique items, of unique elements, and the order of the elements does not matter in that regard. So you could store a list of unique items where you want to ensure that you don't have any duplicates. In the lottery example, one number can only appear once and not multiple times. So if you want to store a list of or a set of unique items, I shouldn't say list, then you store them in a set. So we've got the array, which is basically the same data type stored, a list, which means I can store different data types in this list. And both the array and the list are ordered, meaning there's always one element, which is the first one, the element having the index 0. So that's the unusual thing there. So arrays and lists, the same data types, different data types, that's the distinction there, but always ordered. A set is a collection of unique elements. There cannot be any duplicates there, and we don't care about the order for the set. And in all these examples, with all these collections, data structures, there's always ways to add elements to them and to remove elements to them. Usually you also have operations to sort the items in the array and in the list, at least, because the set isn't ordered. It's just a collection of unique items. And these are typical operations to, get the data out, get the data in, search for data. This is the stuff that you can do with these data structures, arrays, lists, and sets.